you're at year 12, this video is going to go through every single thing we've done about how to find the equation of a plane from 3 points. So it's going to be quite long. It's probably going to be well over 10 minutes. And I may not get to the wonderful fourth way to do this, which is the new way, which is not required for A-level, but it's so cool that I can't not show it to you. So we're going to first go right back to where we started. We're going to work with 3 points over and over, and it's these 3 points. So please get those down, grab a piece of paper. This video is going to be totally boring if you're not actually working through it with me. It's still going to be a little bit boring even if you are. And I'm going to go quite slowly through some bits of the algebra because some of you still need some practice at that. This is just an old textbook example from the Neal and Quadling textbook, but I want you to see how all of the different ways link up. So this is what our 3 points look like, and we're trying to fit a plane through those. So the first way that we learnt, and it's still a really good way, is that we started at the origin and we said, well, let's get out to point A. Here's point A, and let's join up all of the points that are in between. I'm trying to find a ruler on my very messy desk to make this work. Now, I could do this in GeoGebra, but I'd just do it by hand. So there's my first line. It'll do. So that's through A and C. And now I know that all of those points are in the plane. Now, here's my second line coming up roughly. Oh, maths teacher fail. Right, there we are. There's my second line here. So all the linear combinations of those two lines are what are going to make up my plane. And that's the way we do the algebra, matches that big idea. So there's nothing at all in here about normal vectors to a plane or perpendiculars and none of that stuff. That's going to come up later, and that's going to make life far easier. But what we're going to do first is the algebra that goes with this method. So the vector equation of the plane looks like this. It's the point vector to get me up to A, and then it's the linear combination, the mu and these two things are just nut scalars, right? Mu and lambda and mu, like that. So what we have to do now is just make that algebra work. We're going to eliminate mu and lambda so that we end up getting something in the form ax plus by plus cz is equal to d. So I'm going to pause the recording now and I'm going to start doing that algebra, and you should do that algebra with me. Okay, and I'll put the recording back in at key points. Okay, well that's where you should have got down to with the two direction vectors and the point vector for A. So, position vector, sorry. Now we have to turn those into 3 equations, x equals blah blah, y equals blah blah, and z equals blah blah. And then we're going to start eliminating things until we get the whole way through. So this bit I am going to do the usual way where you see what I'm doing as I go. Just forward through if it's too slow. Okay, so there we go. We've got our 3 equations, and now we're going to start eliminating the lambda and the mu. Now, obviously, the simplest equation in there is this first one, the x equals 1 plus lambda, so I'll start there. Otherwise, you're going to have to do your typical level 1 stuff where you do some substitution or elimination, and you could pick any two. But here we're going to start by saying, well, lambda is equal to x minus 1. So we're going to start off and we're going to sub that into the y equation. Some of you may well have faster ways to do this, but this works. Right, so y equals 2 minus 3 times that minus 2 mu, and that gives me now remember my goal is to get rid of the mu and the lambda, so now I'm going to make 2 mu the subject. And what will that give me? It'll give me 5 minus 3x minus y. Okay, I haven't bothered to go on and get mu because I can see that in my z equation I need 2 mu anyway. So let's do the last one. So we're nearly there. So it's not actually that bad once you get the hang of it. So z is equal to 1 minus 5 lambda, which is x minus 1, minus 5 minus 3x minus y. And now we're going to clean that up. That gives me z is equal to, something's gone bad. No, it hasn't. We're good. So you can see that the 5's go and we get 1 minus 2x plus y, leaving me in the end with my equation of the plane. So 2x minus y plus z is equal to 1. So there we go. Isn't that magnificent? Now, if we look at that, we can now read off the normal vector. We might just want to note that down in your maths book for later on, that it's going to be 2, -1, and 1. But we have no way from what we've done of having got there any faster. We had to do it using the elimination method. Okay, now the second way is kind of even more obvious. So here's the second way. I don't think we did this in class, but we can just substitute points into the equation. So this is the equation of the plane. We don't know the constant and we don't know the normal vector, but we do know that all 3 of those points are in the plane. So what does that let me do? Now this sounds really cool. When I thought about this one, I thought this was great. It turns out the algebra is worse, and the chances, if you're me, that you screw it up are much higher. But let's do it once anyway. So I'm going to pause and I'm going to substitute in these points into the equation of the plane. All right, so you should have got down to this, and then you might be looking at it going, okay, well, what on earth do I do now? Well, what we're trying to do, and you'll see it once we've done it, is we're going to try and get everything in terms of D so that then we can stick stuff back in here. Okay, so we're going to start again. We're going to look at, well, there are different ways to go here. So just follow through with how I'm doing it, and you can try it a different way later on. So we'll write those equations up again. All right, so this is where I'm going to start from. I'm going to do 1 take away 3, and that's going to give me the A take away, the A is gone. I get 2B. C minus -c gives me plus 2C. And the reason I wanted to do that is because now I've got 0 here. So that means that I can say that B is equal to, stupid stylus, B is equal to -c. So I can take that equation, and where can I stick it? Well, I can go back up to this one, to equation 2. Right, so we're slowly going to get rid of the A, B, and C. 2A minus B, I'm going to keep everything in terms of A and B now. So get rid of the C, minus B, minus 4, also C is equal to negative B. So minus 4 times negative B is equal to D. So that gives me 2A minus B plus 4B, so plus 3B is equal to D. Now what? Well, I know from equation 3 that A minus negative B is equal to D. So that's A plus B is equal to D. So I've got this one and I've got this one. So we can now combine those two. We can substitute, let's see, where am I going wrong? Okay, so I've got B is equal to D minus A from in here. So now we're nearly there. We've got A in terms of D, 2A plus 3 times D minus A is equal to D. So 2D, simplifying, is equal to A. And that means that we know, what do we know about the other ones? Well, we know that B is equal to D minus A. So B is equal to negative D. And that means that C must be equal to negative B. So C is equal to D. So it all feels a bit strange, but it's going to work. So let's see how that works on the next slide for getting the equation of the plane. remember the equation of the plane is this, ax plus by plus cz is equal to d. But now we've got a is equal to 2d. 2dx minus dy plus dz is equal to d. Now, can I divide through by d? Well, the only time we get trouble with dividing is when we're trying to divide by 0. But we know that if d was 0, this whole thing would just say 0 is 0, which is boring and not useful. So we know that d is not equal to 0, which means we can now divide through by d and look what we get. We get 2x minus y plus z is equal to 1. And at this point, we should be feeling very happy because we're finished. We've got the same thing we got from method 1. Now, I don't know about you, but I don't like that way. The chances that I screw that way up are very, very high. But it's quite good for giving you the intuition that we've got an equation of a plane here, and we've got 3 unknowns, and we've got 3 points. So we can just chug through the maths and figure out what combination of coefficients will mean those points are all on the plane. Now, hopefully you're going to like method 3 much better than I like method 2. So here comes method 3, and this one is one where we finally start to think about the normal vector. So we know that these two direction vectors are parallel to the plane. Let's do the bad picture of the plane. So here's my plane, and we know that AB is in there and AC is in there. So the normal vector is going to be parallel to both of those. Now we're going to call the normal vector PQR, and we're going to try and figure out what it is. But we know our direction vectors. We know the AB direction vector, and we know the AC direction vector. We've got those from before. So this method goes like this. We take the direction vector and we dot product it with those two things. And this is getting us very close to the mysterious and not in the curriculum fourth method, right? But we're going to do this one by hand first. So what we're trying to do here is we're trying to find the normal vector, and we're again going to use simultaneous equations to do it. So I'm going to do that on the next slide. You should work it through too and see if you can get right through to having the normal vector. Okay, so that's the most obvious bit of what we've done. We've just written those two dot products as equations. Now what can I say? Well, I take this equation and I can say that Q is equal to negative R. And now I can sub that into there. So I'm going to get everything here in terms of R. Doesn't matter which way you go, but we'll get P minus 3 times negative R plus 5R is equal to 0. So that should not be a plus. That should be a minus because that is a negative sign there. Whoops, there we go. Okay, so that gives me P minus 2R is equal to 0, which tells me that P is equal to 2R. So that means I've got my normal vector. So that was pretty easy. So PQR is equal to 2R. Q is equal to negative R. You should be noticing something here, and R is just R, of course. And what can I do now? Well, we can choose R to be any number. This is a direction vector, remember? It's the normal vector. So it doesn't matter as long as we don't choose R equal to 0. Let's just choose R equal 1. R equal to 1. Then we get 2, negative 1, and 1. So that's my normal vector for my plane. Now I've got 45 seconds left before the screencasting thing runs out, just enough time to figure out the last bit. Remember that we've got AX plus BY plus CZ is equal to K. Now we don't know what K is yet, but we know that the equation is going to be 2x minus y plus z is equal to K, and we're going to put in a point. So we'll use point C, sub in this, and that's going to generate K. We're going to get 2 minus 0 minus 1 for plus negative 1 is equal to K. Don't know what that is. K is equal to 1. So finally we've got the equation of the plane.